Welcome to Nodes 2020. My name is Ellie Young, and I'm the head of community at the Knowledge Graphs Conference and Community. If you haven't heard of KGC, we're a digital media brand focused on convening conversations around knowledge tech and creating cutting edge content. In addition to our yearly conference, we also host a 1,000 member Slack where industry practitioners, enterprise adopters, and learners can come together to share, discuss, and innovate more rapidly in this space. We also host a variety of lo-fi events like Knowledge Espresso, which is a once a week informal chat with a member of the community on a topic of their choosing, as well as office hours, book clubs, and a newsletter. We're also launching a new event series called No Food once a month, which is an exploration and discussion about knowledge technologies and application to food systems. And right now, we're building out a conference with Connected Data London called Knowledge Connections, which will run from November 30th to December 2nd and feature a variety of speakers, workshops, and tutorials in this space. So if you haven't connected with us yet, feel free to reach out on LinkedIn and I'll get you a link to that Slack and information about our other events. Today, we're going to hear from Wilson Chua about using Neo4J for contact tracing in the Philippines. Wilson is the managing director and founder of Future Gen International and has a master's degree in ITPM and certifications in Neo4j, Tableau, and RapidMiner. So Wilson, please give us an introduction.
And good day, everyone. Let me share with you a story. This is the story about how a company was able to contain its COVID infection while maintaining its operation. In the chart above, we plot the growth and subsequent decline of COVID-19 across time for a factory located in the Philippines. This despite the factory being located in a province that was currently suffering from huge spikes in COVID cases at the same time period. A little background, this company has about 10,000 employees, and when it hit, it affected about 10% of its total workforce. And so the client, fortunately, maintains a lot of data about its employees' movement and whereabouts. And their goal was to maintain operations while keeping COVID infections down to maintain a safe environment for their people. And so the principal strategy that we used here was to trace and isolate early. According to this chart from Johns Hopkins, it takes almost 9 days to get an infected person isolated in the US. So the goal is simple. Trace as many and as early as we can so we can isolate these patients, these cases too. This will lead to a larger reduction in the rate of infection in the factory floor. Hopefully, it will also help to reduce the reproduction rate to below 1.0. So here you can expect us to be sharing some of the best practices and strategies that we applied to this factory case. Just note that this presentation shares the lesson from the lens of data analytics only. Here, data can be harnessed to stop the chain of transmission and help the companies and contain the COVID while safely opening up or while safely operating. So here we collect and analyze the data, we visualize the data, and final fourth part, we will show the actual Neo4j codes. In the case at hand, we found three main sources of data that help us in containing the COVID infections inside the factory floor. And these are the QR code check-ins, the daily health declaration, and company sick and vacation leaves. If you have them, mobile phone GPS and the GP and HPC visits would also help. Data from visitor check-ins are already being implemented in the Philippines. Most businesses are now mandated to keep visitor logbooks. The factory collected data from these activities that are shaded in green. So from going to work and all the way up to going back home, QR codes were stored in their data set. Now, while the rest of the Philippines were still using pen and paper, this factory was already digital. So this this had several benefits. One, it avoided making the common use of pens as a source of infection. And the QR codes enabled them with bidirectional data transfer. So QR code can also alert for what we call persons under investigations or persons under monitoring, which helps them to secure access to their factory floor. And the third benefit is that it's easier when the data is consolidated in one step. Um, so it's easier to generate Neo4J analytics on this one. But collecting the data is only half the fight. So we need to analyze and visualize it for decision makers. In the succeeding slides, I will share some of the insights generated using Neo4j. But here's a broad overview. It is really based on using network graph analytics and visualizing them. So here we highlight how COVID infections might spread across a community and see how effective Neo4j is at mapping the path of transmission across these social links. And as the virus moves across the same social fabric, so too does Neo4j analyze the path along the same lines to generate incredible insights and predictions that help the factory and their contact tracing teams. Here, the nodes, as you all know, are in circles and they could represent people, places, or events. Edges are links and they are shown as lines connecting these nodes. Now, I would just like to call your attention to person A and person C. Person A in network graph parlance has a high degree centrality. These are persons that could become super spreaders if they themselves were infected. Then we go on to person C, who on the other hand is somebody that doesn't have a lot of interactions, but they bridge communities together. So from this perspective, the infection coming from person A's community cannot spread beyond if person C is not also infected. So if we only had 2 shots of vaccine for COVID, I would suggest that we give it to persons A and person C. Person C, by the way, is somebody with a high betweenness score. And this chart was taken from the book by Miss Amy Hodler. So here we show how we use Neo4j Bloom to enable people to use simple English queries to quickly identify contacts. Here, they just type in the keyword phrase, employees with ties to case 81. Case 81 is highlighted in red, and all the close contacts are surfaced and displayed in pink. Now, in this actual case that we consulted for, up to 43% of the positive cases were quarantined early as they were identified using Neo4j as close contacts. This helped to reduce the chain of infections across the factory floor. Hence, this proves to be a vital tool for the factory for its ongoing operation while keeping the COVID cases down. Now, in this next slide, in the Philippine culture and context, we note that some positive cases preferred to delay their testing by up to 3 to 4 days. Now, usually when asked, they would say, we would want to make sure that it's not the common cold or cough. So we gain valuable time by correlating the daily health self-declaration reports to spot potential COVID cases on the same day as when these symptoms were actually reported. We also note that not all people will be religiously complying with the rules and regulations. So we ask ourselves, who else might be similar to the positive and the contact cases? For this, we use the Jacquard Similarity Score to help track people. So in the chart that you see, the 2 red nodes are the positive cases, and the pink nodes surrounding them are the identified close contact. Using Jacquard similarity, we are able to identify 2 more employees that were not tagged as close contacts, but nevertheless showed a similarity score that's very high, and so they warrant additional investigation. It also turns out that providing machine learning algorithms with network graph metrics help improve the prediction accuracy. In this case, one of our key findings was that the community score, betweenness, and degree centrality turns out to be important features that help machine learning algorithms improve on its accuracy. Next, visually presenting the cluster of cases helps management to understand how the cases are connected by time and place. This visual helps them prioritize their anti-COVID measures like disinfection and isolation. Companies can target specific clusters rather than apply a shotgun approach across the entire factory floor. This is the same chart that I showed you earlier, which showed the progression of COVID. And this time, we color code them with their Louvain community score. Can you now get an inkling of how COVID spread across the communities? This is the same chart, but this time we split out the cases so that each community cluster is arrayed across one row. May I direct your attention to the two things? Number one, we show the seeding events here highlighted in green. And we also can show management, the community spread across these three communities, 6033, 2171, and 1282. Next, for communities with limited resources, we can also use network graph metrics to further enhance what pool testing strategies. So here, instead of using 100 tests, by pooling the tests together, we use only 10 tests. Now, if there so happens to be one infection across those 10 steps, we then use additional 10 tests. So this makes for a total of 20 tests rather than using 80 tests. The savings will enable communities and factories and companies to test more frequently. The problem with pool testing, however, is that it only works when the infection case ratio is low. What happens when you have cases where the infection rate approaches 6%, like in this one? Well, this is where the network scores come in. The Louvain score can help communities to bring the cases to the same column. And so here, what happens is you just need only to spend 30 tests for these 100 people. So here are the technical steps that we've taken. First, we ingest the data. Then we do some pre-processing. We compute the network metrics. Then we label exposed people and the positive cases. We compute the Louvain and the Jacquard similarity. And then we extract the CSV and visualize the actionable insights. So after ingest, this is the code that we use to ingest the data. We load it using the command load CSV with headers from the file. And then we create the relationship between the person and the places that they visited. Note that we embedded the details of the check-in into the relationship. Here's the processing step. The QR log shows each person at the location for each time. So we pre-process this to mark who else are also in the same place and at the same time. So we set up the bipartite links, and this is the code to do it. Now, in the interest of saving time, since this is a recording, we will just breeze through this slide. So here we will show how we created we will show how we ingested the daily self-declaration data into the schema as well. One beauty is that we can then also use the shortest path algorithm to surface links between any two cases. This helps us to identify any potential silent or asymptomatic carriers and also potential close contacts that were missed. This is how we label positive cases. Note that for the positive case in red, the close contacts that was identified was the one in pink because their interaction happened during the infectious window of the positive case in red. The blue node on the right, on the other hand, was not tagged as exposed simply because the interactions happened outside of the infectious window of the positive case. The QR log data also shows how we tag employees as contacts only when their interaction occurs within the infectious window. And so once we have identified them as exposed contacts, we can then label, or we can tag the exposed contacts by labeling, adding a label to that employee's node and adding some more related case data like um, the case that infected them and the start of their infectious period. And with that, I finish our presentation. And just before we end, please understand that this is a novel disease. And so these best practices that we presented today are based on the currently available body of knowledge. We expect to update these practices as new information comes in. And what better way to accelerate them than to have a call to collaborate? So please feel free to contact me or our team at the address provided below. I thank you.